Hello guys, today I will discuss force and Newton's law of motion. So, force and Newton's law of motion, short form NLM, Newton's laws of motion. So, what is force? So, force is nothing but push or pull on object. So, I will explain this with example. Let this is the door. So this is the door and this is the handle. If you want to open this door, then you have to apply this force. Okay, this force and this force is push force. So, so this is push and we call it so. This is push and this push is called force. You apply force and the doors open. Okay, now let this is the block of mass m and you want to drag it, you want to move it, and there is a rope. By this rope you want to drag it on the floor, so you have to pull it. So here you are pulling the rope and this rope will drag the drag this block on the floor. This block will start move. Okay, so this is the example of force. Here you apply push to open the door, and here you apply pull to move this block to rightward. Okay, so this is the force. This force is push or pull. Okay, now we will move to the Newton's law of motion. Newton's law of motion. So Newton's law of motion, there are three physical laws which are the foundation for classical mechanics. Okay, so we will move to the Newton's first law of motion. So here, so okay, so what is Newton's first law of motion? Newton's sorry Newton's first law of motion. So Newton's first law of motion says, so first law of Newton says, first law says, if if anybody is at rest, if anybody is at rest or moving along a straight line uniformly, then it will continue to be that state until it is acted by some external force. Let's understand this by example. If a body block of mass m is at rest, so it will remain at rest until we apply some force on it. Okay, if there is no force, then this body will remain at rest. Okay, now in second part of this laws, they say that, let's see this is a wheel and this wheel is moving with constant velocity v, uniform velocity v. So this wheel will continue to move with this velocity, constant velocity v, until it is acted by some external force. Okay, until it is acted by some external force. When you apply some external force, then this velocity change and acceleration will produce. So this law says that if body is at rest, then it will remain at rest until some external force is applied on it. And if body is moving along a straight line with uniformly, then it will continue to be moved with same constant velocity until it is acted by some external force. So this is first law of Newton's first law. Now move to the second law. So what is second law of motion? Newton's law of motion. So second law of motion says that force applied on a body is equal to product of mass and acceleration. Product of mass and acceleration. Okay, so this is F and this is F net. It is very important. This is F net. F net. Why F net? So let's see. This is the block. This is the block and I'm applying force F1 here, F1 here, and F2 force applying from here. So net force, net force, net force will be F1. Net force will be F1 minus F2. So net force will be F1 minus F2, and this will be MA. So it is very important that you have to take net force on the body to calculate acceleration. Okay, this will be MA. So that's why Newton's second law says that the net force applied on a body is equal to product of mass into acceleration of that body. So this is the Newton's second law of motion. Now moving towards third law of motion. Now third law of Newton says that if two body interact, if two body interact, if two body interact, then they apply equal force on each other, and this force is in opposite direction. Let's say that this is the block M, and here is the man. Here is the man. Here is the man who applying force on this block. Who applying force on this block. So this is the boy, and this is the block of mass M. So the boy applying force on this block M in this direction. Okay, and this block mass M will also apply force on the ball in this direction. So force is equal, means this force F force on block M by boy is FMB, and this force F on YB by mass M, by block of mass M. So this force will be equal in magnitude. In magnitude, it is important, but in direction they are opposite. The boy is applying force in this direction, and this block of mass M force applying on the boy in this direction. So the force is equal, but the direction is opposite. This is Newton's third law of motion. Means if two bodies are interacting, then the force then they will apply force in the force in opposite direction but equal in magnitude. So thanks for watching this video. If you enjoy this video, then please like and share the video.